Hey, Melli, how are you?
Good. How are you?
Good, thanks. Hey, Josh, welcome back.
Hey, Vivek. Yeah.
Melli, welcome to Context Ops. We are obviously recording the first season of the show, and I'm excited to have you here. Right now, for the audience, Melli obviously has is a product manager and has led graph technologies for Oracle. She's been at Oracle for 27 years. Right, Melli. While that's the LinkedIn version, right? What I would love to hear from you uh, is your story, your background. How did you end up being at Oracle, and then obviously also staying at Oracle for 27 years? And then, more importantly, more contextually, how did you end up in graph in knowledge management in this domain? Yeah.
Right. Okay. Yeah. Thank you, Vivek. Thank you, Joshua. First of all, it's really nice to be here. Thank you for inviting me. I love talking about Oracle and its technologies. Not surprising because I've been here for 27 years. So I'm really happy to have the opportunity. So, what got me to this stage? So, I did my PhD at Purdue University, PhD in computer science in the late 90s. And before that, I was at the University of Maryland, Baltimore County. But after doing all of this, then I thought, okay, at that time, my PhD was in content-based retrieval of images, which sounds really quaint, given where the technology is today. At that time, we were struggling with like color histograms and texture matching and shape recognition and shape matching to identify that this is an image, or the best we could do was, okay, this is a good logo. Face recognition was so hard. This is quite a bit before neural networks, right? So but it was an interesting PhD. At that point, it was a new work and it was funded by a NASA fellowship. NASA was generating all of these images from their Hubble telescope at that time, and they needed a way to automate the categorization of these images. So they were like, okay, great. We want to find some students to do this. So we applied for and won this NASA fellowship. So it was all exciting work at that time, which, like I said, now sounds quaint. So when I graduated and I was looking for positions and interviewing with companies, Oracle was really interesting to me. One, of course, because they are still the leader in database technology. And it was, of course, exciting to come and work for a leader in database technology. And at that time, they had this product for content-based image retrieval or image indexing. Like, how do we efficiently search through large repository of images? And that fit right with my expertise. I said, okay, this is great. And they're doing new stuff, cutting edge stuff. So I shall go join Oracle. And I also wanted to see what the industry had to offer. I had been in mostly academia at that time. And I said, okay, let me see how people look at these problems from an industry perspective. So joined Oracle, then joined as a developer on the multimedia team, did various development projects for a number of years. And then early on, I think in the mid 2000s, the knowledge graph space, at that time known as the semantic web technologies, began to take shape. And that was interesting, really interesting to me, partly, I think, because of my academic background, that I began to see the potential of, oh, here's exciting. You're not just looking at data as precise strings, you're looking at the meaning of data. And that was really interesting. So I said, okay, I think it's in the development groups, I kind of switched to working with semantic web technologies, did that for a bit. And then Oracle began working, the multimedia team moved into medical imaging, searching and search, efficient management and storage and retrieval of medical images. And there was a semantic element to it. Like even then we were talking about patient health records and how do you match terms across different technologies. The imaging folks might use different terms, physicians might use different terms. How do you match things across all of that? And as I think as we and Oracle keeps moving with different technologies, which is why I ended up staying with Oracle for so long, right? It's very good at understanding what is the latest wave and how it's relevant to customers. So then there was a big data wave, I think, if I'm remembering correctly, Hadoop platforms and so on. So we were doing some work on that because my work so far had been in what we termed as unstructured data, like not strictly rows and columns, but images, audio, video data. So that was of interest to folks, but managing these large volumes of data on a Hadoop platform. And then from there, then graph analytics, property graph analytics began to become interesting. And by this point, I had transitioned into product management simply because I like working with customers. I like looking at the bigger picture. And I like the thing about solving real problems. When I love the idea of applying technology that we have to the pain points that customers have. And then property graph analytics, this is the mid 2010s or late 2010s. Property graph analytics was kind of an ascendance, doing data science kind of work, analyzing your data from the point of view of a graph, like identifying key entities in your data, how entities are connected, things like that. And then the AI era started, and then it's all about knowledge graphs these days. And I had the knowledge background, so it was kind of easy to move back into it. And in any case, I was product managing both graph models in the database. And this might have been way longer than you really wanted, but this has been my journey in my career so far.
Thanks. Very, very interesting, very deep. Uh, yeah, and like the fact that you have so much context about AI, about semantic web, knowledge management, right? Now, let me start with a very counterintuitive question, Melly. Given that you've been at one org for such a long time, and you have seen customers evolve, customers adopt technology over decades now, right? What is it about knowledge graphs and semantic web uh, that people still don't get right? What is it that is most misunderstood about these technologies, right? Which is sort of which is limited their their widespread adoption.
So I'll start from the beginning, I think, from the mid 2000s.
Yeah.
Why this technology was not broadly adopted then. My takeaway from that era was this technology is powerful, but difficult to understand in the sense that there is a learning curve. I've had innumerable customer conversations where typically we would start our engagement, let's say, with a developer team. They really engage, they really like the technology, they are in it, they've learned it. And then when it moves into production, senior management will come in, look at it and say, well, I can solve it these different ways rather than trying to train my teams to learn this technology. I mean, you had all of these strange acronyms like RDF, OWL, Sparkle, like SQL has amazing staying power. And if you had to bring a whole new language, Sparkle, to it, that's like people have to learn Sparkle. People need the tools to work with Sparkle. Like it's better to fit the ecosystem, which is why Oracle has basically a SQL wrapper on Sparkle. But all of these challenges, and senior management will look at these challenges and say, well, we can solve this problem in other ways. So why should we go through the learning curve of understanding semantic web technologies? And related to that is all, like I was saying earlier, that the tooling issue, it became its own custom ecosystem, which is great in academic environments. You have your own ecosystem, it's powerful, you use it. It's very hard to make that work in production environments because then you had to bring the whole other ecosystem with it. And we continue to have customers who loved it. So I saw the world as being divided into RDF aficionados, people who loved RDF technology, and people who decided they didn't want to be bothered with it. And the people who loved it, they would go to great lengths to make it work. So that's one aspect of it. The second aspect of it is, I think the problem they tried to solve was a significant problem. It's been a problem since I've been in technology, right? The whole issue of integrating data from multiple sources, linking it accurately, and really understanding it. It used to be called master data management, one version of it. And then you have the semantic web technologies. And I've talked to enterprise customers who say, we have all of this data and this data silos, and we're not making use of this data. We want to make use of this data. But to go from that question to a successful implementation takes time and effort. And that's where senior management is going to look at it and say, oh, I don't know, this is really not going to work very well. So successful customers are those who invested a year and a half to 2 years. And then they start seeing the benefits. So I think this was a challenge with the technology always. It needed significant investment upfront. What's happening now, and I don't know whether now also is a flash in the pan or whether it will actually have more substance to it. I think what's happening now is AI is the big promise. And knowledge graphs are seen as a tool for more trusted AI. And customers don't want to lose the value that AI can bring. So perhaps they're ready to invest a little more in creating these knowledge graphs to better leverage the benefits of AI. So the incentive might be stronger. Like early on, it was more data integration. Okay, I'll just do data integration a different way rather than invest in this technology. But now, maybe in order to get the benefits of AI, there might be an incentive to invest in this technology. And I don't know. I don't know whether this is a flash in the pan or this will actually be substantive and it will actually go somewhere. We have to see. But I see more investment. There's no question that I see more investment from enterprises in this area now.
Okay, a follow-up question on this. What, despite all the hoopla, all the excitement, and in all fairness, right, a lot of this investment is also being triggered because of very limited progress made from a deployment production perspective over the last 3 years with with what now can be called as conventional RAG approaches and so on, right? Uh, simply adopting a knowledge graph does not imply success, or does not imply that your agents will work as you expected them to work. Knowledge graph is one of the tools. Simply because you have a graph database, only means so much, right? The question then becomes, why would this tale fail if an enterprise if a leadership team who might not have been, let's say, brought up to speed on semantic web, on knowledge management, ontology, which, by the way, are are information architecture, concepts, right? These are not concepts that you learn over a long chat GPT chat session.
Right.
I mean, I wish, or the way Matrix, you load a chip and you say, now I know how to fly a helicopter. I mean, that's not how it. I wish it worked like that. So, I guess the question then becomes, why would it? How could it fail now? How could it still fail despite all of this, amazing momentum, right? Like the fact that Knowledge Graph Conference itself had like peak attendance this year, which is a testament to what you just said.
Right.
Right. Yeah.
How can it still fail? That's an interesting question. Well, first, I'll start off by saying I hope it doesn't fail because we are investing a lot in this and we love the technology. And we think it's powerful technology and we hope it doesn't fail. So where can it still fail? I think the lines are not clearly drawn yet, at least from what I see. The lines are not very clearly drawn between what an LLM can do or what a statistical search like vector search can do and what graphs can do. You can solve some of these problems with just a pure vector search. It might be a little less precise. It might have, because it's statistical by nature, right? And so that might be enough because folks going into production, they need to do this fast, right? They don't want to spend a lot of time on this. They need to get going fast. So if an LLM alone or just the vector search combination with other things alone can do it, it might be good enough. I don't see, I have not seen, I've seen lots of examples, and here is where the statistical search is not good enough. And we absolutely need this more precise relationship concept-based, keyword-based search. I've seen this in a lot of examples, but I haven't really, people at conferences, they talk about this, but I haven't really seen a thing where, okay, this is why this will always work. Like when something else improves, when LLM improves, what would happen? I don't know. I think where even when LLMs improve, where I see the value is ontologies can bring you new relationships and new entities and links that are in your business that an LLM might not know. I mean, just to give you a completely, I guess, awkward or made up example. Like you can say that revenue, if you're asking the LLM about revenue and the LLM knows that revenue is the same as profit, right? It knows that. But if I wanted to equate revenue to completely something else, if I wanted to equate revenue to the number of people I have in the organization, I told you it's an artificial example. If in my business revenue means something else, if revenue means how many people in my business I have happy workers in my organization, that's something an LLM doesn't know because LLM is going with facts that it already has. Or it's being trained on facts that it already has. Whereas a knowledge graph gives you a succinct way of representing specific knowledge that is for your enterprise. You can also give it as paragraph. This is where again I don't know the answer. Like you can explain all of this in paragraphs. In my organization, revenue is not just a profit. Revenue also means how many happy workers I have, and that's text that you can give to the LLM. But LLMs do seem to do better when you are, I think, have a very precise way of representing this. So I think there's still value. There'll always be a value for knowledge graphs. I don't know how much it will be. It might be that LLMs are doing so much that knowledge graphs are a very small, I don't want to use the word niche here, but a very small piece, small but important piece of the whole thing. At the same time, it might be that no, knowledge graphs really being value. I think right now, from where I sit, it feels as the answer is somewhere in between. I don't think knowledge graph is going to be the key solution to all your problems, but I
Oh
think
my
it's going to be an
God,
essential piece.
Melli, what are you saying? People are selling, context graphs and knowledge graphs as if, it's the next, like slice of bread. And hey, you are saying, that knowledge graphs is not it. Oh my God.
I've been through many cycles of technology, right? There's always this great thing
Yeah.
about, okay, this great technology, and they all do some things knowledge graphs do some things very well. I think it's the mistake happens when they try to take that technology and solve everything. I mean, the same thing
Yeah.
with Hadoop happened, right? Hadoop did some things very well. But then people say, oh, we want to build a database on Hadoop. We're going to have Hadoop do OLTP systems, and that's the problem. You have to figure
Yeah.
out that your stuff is going to do something very well, and you have to use it for that right thing, not just try to solve the world with it, I think.
Yeah. All right. I want to go back to a specific word you used very casually, ontology. Right. Now, a lot of people, just like the word knowledge graphs, it has started to be used very loosely in a lot of varied contexts. Then
Right.
there is like, context graph, which is not even a defined word in the semantic web dictionary or glossary items, right? How do you explain ontology to an enterprise customer who is starting to think about, exploring knowledge graphs as a means to the end?
Right. So I define ontologies as a schema for your data. It's kind of a way of representing the meaning. I know meaning is an overused term, but it's a way to represent the meaning or knowledge that's embedded in your data. So it's a precise way to describe your data is what I kind of put it in the schema world, though I know ontologies doesn't only mean schema, and to go into the knowledge graph terminology, it's not just the T box. It can also be the A box. It can also be the instance data, and it's a lot of because of I think the RDF folks who came up with RDF wanted to have a lot of flexibility. There's a lot of blurry lines here, but I think enterprises don't like blurry lines. They like precise terms and definitions. So I choose to go with the fact that ontologies represent a knowledge schema for your data, where you can use it to say things like, this is my primary key, as one of our customers is recently doing. This is the primary key I have in my data. And this is this particular entity is related to this particular entity. It's a subclass of relationship. So that is how you describe your data at a high level. That's how I talk about ontologies.
So in a
Thanks.
lot of ways, this could kind of like relate back to SQL. right? It's what I'm thinking when like, you define schema,
Yeah.
you define like tables, and we have like similar things like you can reuse SQL itself as kind of the storage layer for such a thing, right? Is that something that you would say, or am I going off?
Yeah, no, definitely. And I think because we all come from the SQL world, I mean, I have been embedded in this database world, SQL database world for many years now. Definitely that influences my thinking and thinking of when you're working with data, you need to define the structure of your data. Without defining the structure of the data, you really can't work with it well. And as you said in SQL, you have tables, you have the schema, and you have foreign keys and primary key relationships. And that's how you describe the structure of your data. And ontologies can help define the meaning of your data. So definitely that thinking does influence the way we look at an ontology.
How about things like when you say meaning? Um, so ontologies also have a lot of natural language where they can't help but use human words to kind of associate that meaning. It could be metadata, it could be a description. Uh, so how do you look at that in the grand scheme of things? How does that tie back into this model? Like schema plus this thing, how does that tie in?
So I think of natural language as a query language in some sense. So that's how you interact with your data. So you use SQL to interact with your data. Now, increasingly, people want to use natural language to interact with your data. And when you're using natural language to interact with your data, ontology as a schema is very helpful because it describes your data. It can translate into you can translate your natural language queries into it can help translate your natural language queries into something that matches how your data is structurally stored so that you can get better answers or more trusted answers, I think is the word that people like to use these days. So so far I think of natural language as a query language. At least uh, that's the way, to me, it's helpful to think of it that way. And in fact, when you're talking about programming and using, so I was listening to this webinar about using agent programming and so on. I was thinking when I learned programming, I learned it with C and then SQL and so on. And I think now for the kids these days, we have to teach some programming about using natural language to map to these things that you want the machine to do for you. And
So
ontologies, I think, have it all there. Yeah.
yeah, so like so one part is definitely like the natural language being converted to machine readable language. So I think there's a wave of things happening there. There's natural language SQL, there's natural language Sparkle. But I'm trying to kind of just uh, peel the onion on ontology as schema plus what, right? And so if you have annotations in the on top, so one part of it is classes and relations to other classes, and you have a schema. You might even have instances, right? But something that we also see is like some kind of annotation. And originally, it was meant for us. Uh, do you see some use or utility for those annotations to be used by the machine? How do you see that fitting in as well?
Right. Yeah, so that's an interesting question. So I'll fall back again on what Oracle has been doing in this space. So we have now the ability to add annotations. I think now it's called comments. So you can like describe your tables. So you can say that this is my customer table and this is what it contains. And these comments are really useful context for an LLM or agents or who's going to use this data. So I think those things have a very important role to play, and they can be natural language because, of course, LLMs understand natural language quite well. The question to me is, where do ontologies fit into this? Again, so ontologies are more precise mappings of these relationships. I mean, there could be there might be some ambiguity, or there might be, when you talk about annotations, you're talking about text, I presume, which describes something, versus an ontology, which is a more precise or structured or standard-based way of describing something, which is also shareable, right? Because it's defined by certain standards, it becomes more easy to share. Like you're sharing in an enterprise between one part of the organization and other part of the organization. Having an ontology to describe your data is, I think, more easily shareable and usable in a programmatic way than the annotations, because the meaning tends to be precise. That said, the annotations, I mean, they're all useful. Yeah, so I think this is where we have to still figure out how all of these things fit together and work together.
Got it.
So
Now,
you mentioned one thing. Sorry. Yeah.
go on.
So you mentioned context as one of you're basically one of the ways that Oracle is using this is like comments and annotations. What other ways are you all thinking or are you all seeing in the enterprise space in use cases of context coming in or being managed? Like, what are you seeing out there?
So that's a good question. Comments or annotations has been an important feature for, I mean, not just for context, but for any application to kind of use it to understand more of what that data is. I think universally, it's kind of understood that applications need, the more an application knows about your data, the better it is for the application. So, and also developers leave, developers come back. We don't want to be left with pieces of code or schemas. I've talked to customers who they have this code base with these tables, and somebody leaves and they have no idea what this means. Right? They have no idea what this means. They're afraid to touch anything. And I volunteer for an organization, same thing. We're so afraid to touch this code base because it's working and we don't want to change anything. I think context helps there as well. It's a kind of a description that's kind of tied to the data. Like in our context, it's kind of tied to the table. So you can easily find out what it is. So describing what's in this table structures, I think it's valuable for multiple reasons.
So as much of description, everywhere would be really valuable as you even utilize the structured database as well as context to drive things forward. That's what I'm getting.
Yeah.
Got it. Okay. Now, Melli, one question that we get all the time, and this is also partly because the vocabulary is slightly broken today, unfortunately, is enterprises come into us at Cognitive Switch and ask us, can you help us build an ontology? And this is, an enterprise operating in a well-defined category, well-defined industry like a pharma or manufacturing or life sciences and so on, right? And it's a question they are like they start with because this hype and hoopla is creating this FOMO where everybody is saying own your ontology, own your context, own your meaning, and they have obviously very little clue about it, right? So one, how would you break down that request of like, so what are the prerequisites? What do you actually need to build one? Where do you maintain one? Is it a once and done effort? Is it an ongoing effort? Right? How do you actually operationalize it? These are some natural questions which these teams, which are typically non-technical in nature, right? In their background, they come in with, right? And the more they read, the more they get confused, unfortunately today. So yeah, how would you approach that?
Right. So I think, So some customers come with an ontologist on staff,
Yeah,
and then
correct.
it's an easier way to do that. And I think compared to what used to be the past, it is more dynamic, like you said, right? I think the ontologies are going to get updated. I think in the past it used to be ontology was a static thing. You used a tool, you generated this ontology, then you used it in applications, and it rarely changed. But now it changes more dynamically, and we keep hearing these customers' requests, and we have some features and products on our roadmap to make this more of an interactive process.
Mhm.
That is assuming there is an ontologist who understands the core technology and it's and is able to contribute to that. If you don't have that background, it's still not easy, I think, with the technology. I think it still requires some expertise to get started with creating an ontology. So a couple of things that, again, given that I work for Oracle, a couple of things that we have been experimenting with is one, of course, is the way to get an ontology from your database tables. Right, but you might have known there is the, I think, the R2RML standard, which is a way to map your relational table to an ontology. And with the right tools, and we have some tools to automate that, that's a starting point. So you say, here is my data. I can create an ontology from this data, and this is what it looks like. I have these classes, I have these relationships, and so on. But after that, to keep it up to date and maintain it, you still have to have some knowledge. I think it's impossible to not do it without any knowledge. So we say, okay, start from there. That's your data. The other thing is we constantly now get questions from people of saying we have all of this unstructured data, which is what we want to bring into our ontology. And for unstructured data, what can I do? So that's where we have been on our roadmap again is some work to experiment with using AI services to create an ontology from the document itself. So I have this set of documents. I want to understand what are the key things in the document. And of course, AI is very good at summarizing documents and identifying things. But it's also, it will do that. But it can you identify where we find that the tricky things emerge is that you have used AI with a set of documents to get an ontology, then next batch of documents come in, and the term is just used a little differently, like Oracle USA versus Oracle Corporation. You need to know enough to say, I want to use Oracle USA as the term. I don't want it to say Oracle or Corporation is a different term. I need to be able to create that mapping, and that's still not really done. I mean, that's where you can have vector search. You have to say, okay, these are really similar, and then you start getting statistical probability in there. It's not precise. So I guess the short answer to your question, you can start with existing tools. You can start with the relational data or your unstructured data, your documents. But some knowledge is helpful to kind of bring these two together, map this thing together. And I think it's not possible to do this well without a human in the loop. It's not possible to automate this. You do need a human in the loop. And what we are focused on is providing the tools to help this human in the loop do this work successfully and come up to speed successfully without worrying about all the details. Because I want to avoid, as a product manager, I want to avoid what happened last time is you need to invest 1.5 years to get going with this. I want people to get going with it with a much shorter investment to be successful.
Makes sense. All right. So that's very helpful. Now I want to go back to something which you presented at the Knowledge Graph conference, which is agents operationalized in the database. Right. Most people think of the data silos as at the base, some sort of a transformation pipeline, the actual database, which can be a graph database, which can be an Oracle or whatever else there is. Then like a knowledge graph sort of a structure, right? And then the agent layer accessing this information, going back and forth for a specific use case and so on, right? What you presented or what you told was you can collapse some of these layers into one potentially, right? Can you explain that a bit more?
Right. So by collapse that we mean, I mean, you can do all of these things in one database or one server and one instance of this one product rather than have multiple different things and having the ability to communicate between them. So that's the approach we have always taken with our what we call our converged database approach. So because your business data is in your database, so this is really important data. It's your airline reservations, it's your bank transactions, all of this really important data, so important to so many people's lives around the world, is sitting in a database somewhere. To do interesting things with it, you shouldn't have to take this data and move it to a different system or move it to a different layer, to use your term. It would be nice to keep everything, to really be powerful to keep data where it is and do this interesting new analytics, like graph analytics was new, and knowledge graph is now getting a lot of popularity. I want to operate on my data using these technologies, keeping them in place. Like actually the KGC, one of our customers was presenting, as he said, he liked this approach because he didn't have to go and ask his chief security officer anything. He didn't have to ask, oh, do I have to move this data into a different thing? Do I need to get approvals? Do I need to get permissions? It's all there. He had the database. He had the skills because we have a SQL layer for everything. We integrate this into all the tools that he was using. So he was able to do it right in the database. So rather than taking the data to these technologies or to these different algorithms, we like to bring the algorithms and the technologies to the data. So we have integrated, we have our property graph technology, knowledge graph technology, vector search technology, or JSON or any other technology. They work on the database. They all have a SQL API. Like in the RDF knowledge graph case, there is Sparkle, the standards. We allow you to query the data with Sparkle. We also wrap it in SQL to allow you to use SQL and SQL tools immediately, BI tools, everything can make use of them, right? So that's the advantage with that. So everything runs, I mean, the layers as you speak, that you speak of are all kind of layers in the database. You have the data stored, you have some PL SQL packages for creating these agents. You have new SQL APIs for creating a graph and for querying the graph. So all of them happen within one database. It basically simplifies life for our customers. They don't have to worry about security, auditing. All of those automatically apply, right? And we are really focused on security now, given the various things happening in the world, AI world, and so on. So we have this deep data security where you have security right at the source of the data. That policy will apply whether you're treating this data as JSON or treating this data as a graph or using this in a vector search. The same policy applies. We don't have to change anything anywhere. So we kind of collapse these layers into being part of the database.
So what I'm hearing you here say, Melli, is um, instead of having like people talk about a graph database separately, like a Neo4j or something else, right? You can have all of those modalities, a multimodal model here, right? Within one database. How about like how do you define what an agent is? Uh, like, could you briefly run through what you would call an agent?
Yeah, you're exactly right, Joshua. So how we describe the multi-model database, that's exactly right. So for the agents, we have a PL SQL package. PL SQL is a procedural language for SQL that we have, and we give you the ability to create an agent and then create a tool for doing a particular function. Then you can have teams of agents that are working together. So you can have tools, you can have tasks. So all of these are PL SQL API. So we say create a tool, and then we have some code in that. Or create a task that uses these tools, or then create an agent and create teams of agents that work well together, which is what we were showing at KTC. And what we recently did, I think last week, in one of our Ask Tom sessions, which is one of the sessions we do to update folks using our technology. We do these sessions. We have these monthly sessions. We used an agent for working with property graphs and an agent that was working with our knowledge graphs. And we said, okay, we want to find financial fraud in here. So the agent was actually able to find the money transfer pattern from the property graph side and look at an ontology that a financial institution might have about high-risk jurisdictions and so on. And I looked at that. So we have different tools looking at different elements of this fraud investigation and bring them together. So what I described just now is completely SQL and PL SQL based. Of course, we have tools as well. There's the, I think, private AI agent factory that it's called, that would give you a no code interface for bringing these different modules together. I hope
Okay.
that answered your question.
Yeah, partly. So, like for example, an agent in this definition is basically an LLM agent, right? And does that, and of course, you like you mentioned, there are tooling, like describe tools and skills that the agent can use, describe the goal or the objective for that agent. And my question, like another question on this would be, like which model does it connect to? Does it connect to a proprietary model? Does it connect to any of the LLMs out there, or an open source small language model, or like what does it connect to?
Yeah. So Oracle has always taken an open approach with these types of questions. We don't lock ourselves, or we don't lock our customers into any model. Customers can use a model of their choice. We also, of course, have our own generative AI service running on Oracle Cloud infrastructure, which also supports a bunch of models. So when you're creating an agent, how you would do this once again in PL SQL or SQL, we have the API for saying, okay, first you create a credential, and then for a particular service, and then you choose your model, which I think our API is called create profile. And the profile will actually list the model name and list also the database objects that you're going to be using in there, a property graph or tables. It'll list the objects. So once you create the profile, that profile name is then used in your tooling. You're going to say, create this tool and use the profile. So then it's going to use that particular model and that particular service that you have defined based on the earlier authorization steps that you've done to set things up. So somebody using this technology has the choice of any model of their choice.
Got it. And so that means that at some point,
Okay.
at least for the LLM, you would be sending. So one is the database part, which is one layer, multimodal, all in one. But for the LLM, this would be over the cloud. Like this would have to be sent to another system, is what I'm hearing.
Something which you spoke earlier, which is graphs is a means to the end, right? It standalone does not mean that, simply because you ran a LLM to extract entities from a bunch of PDF documents, and you stored them in a node entity relationships or stuff. Like, it only means that you have some sense of your data, right? But there is a lot more work to be done, right? What I want to understand from you is, because you would have seen both successes and failed implementations, right? What is it about knowledge graph implementations, or projects which have failed, right? What does that failure typically look like? Is it the modeling? Is it the loading? Is it the query performance? Is it lack of semantic data understanding? Like, what about it? What are some early signs that teams should be cautious about, to avoid that state altogether?
Right. So this is a multifaceted question. I'll try. I mean, the projects fail for a variety of reasons. Let me try to answer it. I look at it from a couple of different points of view. I think one reason where the things fail is when they, what I use the term over engineer, like have more of a knowledge graph in the mix than you need to. Like you have relation tables. Your best road to success is to create a knowledge graph that can work with the relational tables rather than try to convert all of that relational data into a knowledge graph. And the reason why is, one, the volumes could be high, right? And you would have tuned this relational system to really work well, and now we convert it to knowledge graph. You have a whole different set of tuning things to deal with. That's one. And then keeping data in sync becomes a major headache, because you're having some data and you have all these applications talking to this data, updating this data and doing stuff. And then if you're going to convert it to knowledge graph, you're not going to be able to convert all your applications to fit in with that, right? So you're always going to have the sync problem. You're going to have you got to create these relational tables and then convert always with the existing the structures, and then always keep converting them into an ontology. So that's one thing, that the whole over engineering is a problem. I think you should use knowledge graphs wisely where it needs to be used, and not think of it as the next thing to slice bread and say, okay, I'm going to do everything with my knowledge graph. Relational databases are very good at certain things, and you should keep them for those things. There is no need to change that. But new things, you want to do new things with your data, that's when the graphs come in. So I think that's one way in which this whole thing fails. Second thing is, yes, performance. I mean, you have to think about the data differently when it comes to tuning and designing it. And if that's not done well, that can also lead to some confusion, familiarity with tools. There's new tooling, and the tooling landscape is mature. It's not still as mature as it is for SQL databases, essentially. So having all of this plugin, like people will do this and say, oh, I did all of this wonderful work, but I can't access it from XYZ tool. I had to go use this new tool. And that those things also, like when it fits into an enterprise environment, these are the things. And finally, we have heard from customers who are using competitors' products, and they build it, everything, and then their chief security officer completely shuts it down and say, no, I'm not bringing this new unknown vendor into the system. So sorry, you got to go back to the drawing board. So many different reasons why I think projects fail. I mean, which is basically new technology has to fit in. There's also this tension between IT and developers, business development folks, and they had to make sure they're in with the IT way of doing things. All of these reasons, which is why we collapse these layers in the database, because we think that's your best bet to success. Best road to success.
Perfect. No way. Thank you so much for this conversation. It's been very interesting, right? I think for the first time we've had somebody on the show who has come in and sort of spoken so candidly about graphs being just one tool in the larger, toolkit that you have, and they should not be looked as the destination, which should be looked as one big milestone in the journey. Right. So yeah, really insightful conversations. Lots of technical details. Right. I'm excited that I had Joshua here as well. But yes,
Sorry,
this is a
sorry.
good conversation, Melli. Really appreciate you taking the time today. Uh, one last question which we ask all our guests is, if there was one thing that you could change about how enterprises do this, and it actually happens tomorrow, what would that be?
One thing that enterprises would do to actually, I think I'll go back to your ontology development question, right? If there was a magical way to create an ontology for an enterprise, I think more work needs to be done there. So that could be kind of magically done, so that you have, okay, an enterprise is ready to try this, and they can easily create a knowledge graph and easily integrate it with all the other technologies. I think then you're taking away the initial pain of doing things, and you kind of get to a stage where you can start using the technology and start working with it. So from my perspective, who would love to see knowledge graphs adopted widely in conjunction with relational data and so on, that is a pain point, getting to that starting point. So we see the success with customers when customers already come to us with an ontology and they have it all planned, and they say, okay, now I want to see how to operationalize this. Great. But when they have a higher level question that I want to solve, then it takes a longer time to get there. But increasingly, we are finding customers coming to us saying, okay, we have this different entity, we have this knowledge graph, we have this data, we have these documents, we want to make things into production. So they're clearly investing in this before they come to us, which is, I think, a good sign for success of this technology. So in coming back to your question, what would I like to see? I would like to see all our customers have this knowledge and have this knowledge graph, the ability to create this quickly, so you can move ahead with their actual problems.
The funny part about this question is almost none of the guests on this show have ever answered that question with, I wish we had Mythos access or Fable access or access to that model. They've all anchored their their wishes or their dreams in the absolute boring, painful things, like you said, which is building ontologies, understanding your taxonomies a bit better, and so on and so forth, right? It seems like Fable and Mythos are only, like they're not the magic wand, at least for guests on this show. Yeah.
Not yet, at least. Yes. Yes. And thank you for this conversation, because it's always helpful to have a conversation like this, right? Always also clarifies things in your own mind. So it's always enjoyable. Thank you.
Thanks.
Thanks, Melli.
Okay, I'm gonna